Hello, this is Sam. Today we're going to learn on and about weight, volume, and density. So let's go. This is called weight, this is called volume, and this is called density. So let's go. So we can measure the amount of any material in two ways, which is weight and volume. This is called weight and this is called volume. Volume is nothing but it's where it takes up space. Weight is where it takes up like so much heavy. I mean, it's like heavy. So how will you measure the given below items? How will you measure this fresh milk in bottle here or this? So we use some items and we'll see. When you buy milk or petrol, you measure its volume in liters. Thus, you buy these by measuring how much space or volume they occupy. But when you buy rice and potatoes, you measure their weight in kilograms, like through any machine, something like that. So thus you buy these by measuring how heavy they are, and that is by their weight. So volume is like it's a measure of amount of space an object takes up, as I told before. Common units used to express volume include liters, milliliters, teaspoons, gallons, or extra. So, weight of an object is the force acting on the object due to the gravity. So the mass of an object will never change, but the weight of an item can change based on its location. For example, you may weigh 30 kg on the earth, but you can weight less. Like you can weight less in outer space. So what do you think that do mass and weight are same? Well, we'll just see here. What is the relationship between the volume and the weight of the substance? When the volume of a substance increases, its weight also increases. The more the weight of the rice you buy, the greater will be its volume. So here, as you can see, 1 kg, 2 kg, 5 kg. So volumes of the different weights of rice, volume of 1 kg of cotton. So this is really bigger than if you combine these all, but it just weighs 1 kg. But these, if you add all of them, it's like around 8 kg. So like this is volume, this is weight. They use this item, something like that, to measure. So if you buy the same weight of cotton, wool and rice, which will be heavier? Do you know? So the answer is cotton wool, because the cotton wool is lighter than the rice. So different materials have different volumes for the same weight. So if you take equal volume cotton wool and rice, which one will be heavier? So it will be, of course, rice, because equal volumes of the different materials have different weights. So here, density, weight of unit volume of a material substance. So D is equal to weight by volume. Density means that if you take two cubes of the same size made out of different materials and weight them, they usually won't weigh the same size. So density is defined as how tightly or loosely packed in a substance is, or two, the number of things or prepare a certain area. For example, like density is a population density. which refers to number of people in a certain geographic area. The greater the density of substance, the heavier it feels as the molecules are packed more closely together. So here is an example of the density. These two objects are equal in the volume but different of mass due to their density. Here low mass, because the molecules aren't tight enough. Here the high density. So molecules are really tight and there are more. What is the purpose of density? So like density is an important concept, because it allows us to determine what substance will float, what substance will sink when placed in a liquid. So generally like a substance float so long as the density is less than the density of the liquid they are placed in, like cork, wood, aluminum. So here cork is really light. These are all waters, okay? Don't think it's petroleum or oil. These are all waters, as you can see here. So like this is a cork. I mean, it's like so light, so that's why it's on the top. This is wood. It is really heavy. So you can see it went a bit down, but it didn't sink. But the aluminium here like it's sinking because it's 100%. I mean like density is more. So floating and sinking, you might have known or heard it. So float means like floating on the water. I mean like how can like here there is an activity. So a penny means a coin. So of course it sinks. Paperclip, it won't sink. So pencil would probably sink. We don't know. I mean, it depends. Like which type. Ping pong, it'll like float. A rock would probably sink. A spoon, which is somewhat, I mean, it's metal, so not wood, metal, so it would sink. If it's wood, it would float. A feather will float. So water means to stay above the surface of the water. Like sink means like it goes below the surface of the water. Here as an example, football is on top. Not what am I saying? Basketball is on top of the water, surface of the water, and this whatever the ball is called, it's below the surface of the water. So it is the density which decides whether the object will float or sink. So some objects float and some others sink, as you know, as before an activity was given. Few of them sink, few of them go and float. Objects such as pebbles and balls sink in the water because they have a higher density, are denser than water. A piece of cork or wood will float on water because it has a lower density, is less denser than water. So water and density. Here water has a density of 1. If an object sinks, it has a density greater than 1. If an object floats, it has a density less than 1. Wood is less dense than water and it floats here. This is wood and it floats, but this rock has more density than water, so it sinks here. Oops, sorry. So conclusion is, if an object is denser than water, it sinks in the water. Just simple. If an object is denser than water, it sinks in the water. But if an object is less denser than water, it floats on the water. As you can see here, wood and here oil water and sand water. Oil and plus water, you will like see, like oil will float on the water, it will never sink, but sand will sink in the water. So which is denser, petrol or water? What do you think? Maybe you're right, not you. I don't know, but water is denser than petrol. Petrol floats on water, which means that water is higher density than petrol. If the two components are put together in the container, petrol will float as the two do not mix, and because the petrol is lighter, as you can see here. So since the water is denser, one should not use water to put on fire caused by petrol. So whenever the fire comes due to petrol, you have to not put water because it's light. I mean, it's the water has high density, so it can cause more fire, something like that, or like petrol will float on it, so cause more. So here, as you can see, this is petrol. It looks a bit weird, but yeah. So some research on the following questions. So you can research these following questions, like, are gases less denser than water? Is there any gas which is heavier than water? Why does ice float on water? So you can just comment down below. Like for these, you can take a screenshot. A piece of iron nail sinks on the water, but we have already learned this because of the shape, because of the volume of the ship. Do you feel force pushing your hand upward? Okay, so this is buoyancy and upthrust or upthrust. The weight of the object, this is the object, and the buoyancy force is like just trying to throw it out of the water, something like that. Buoyancy or upthrust is an upward force exerted by a fluid that possesses the weight of the particularly or partially fully immersed object. This upthrust act on all the substances, like when they are in the water, that affects in all substances weightless in water. So have you ever experienced like this? Why do we weight very less in the water? So, as per Archimedes principle, this Archimedes principle, it's like a water exerts an upward force or the buoyant force on our body. This is because the weight of the body is, the weight of our body in water is equal to apparent weight. As a result of weight of our body reduces, thus we feel lighter when we are in the swimming pool due to the buoyancy force. Sorry guys for the delay. So I was about to tell what does Archimedes mean. So like, um, 1 second. Archimedes principle is nothing but like one of the examples, as I told. You have seen that the iron is denser than water, so a piece of like iron sinks in the water. So then, like, why does huge ship made of iron float in the water? Let us see why. So we have already learned that before. Like, take a piece of wood. There's an activity. So take a piece of wood and drop it in a half bucket full of water. The wood will float. So push the wood down into the water with your hand. Like, do you feel any force pushing your hand upwards? You might have, done many stuff like this. You, while maybe you do some things and that is related to it. So you just keep you mean like for example a glass or a bowl you take and then put something in. For example, take balloon or take any small piece of wood and try pushing it downwards. The bowl or the glass, I mean, should be really big. I mean, like around more than a meter or something. So then you just try pushing it in the water. So you might feel some force like you're pushing your hand upward. So that is the thrust. So take your hands off the piece of the wood. So will it come back? Yeah, it will come back. So this shows that the force acts on the wood in the upward direction. When it pushed into water, this force is called upthrust or buoyancy force. So guys, don't think you got stuck here like I've been telling you. So like here, therefore, because the 10 kg object displaces 4 kg of the water, it feels like its weight only 6 kg underwater. 4 kg of water displaced by buoyancy force is equal to the weight displaced. Oops. The displace. So here, as you can see, the Archimedes principle states when an object partially or completely immersed in a fluid means water, any liquid. So it experiences an upward force which is equal to the weight of the fluid displaced in the water. So as you can see here, guys, you can just read. We have seen like apparent weight of an object is equal to true weight of an object in the air minus the upthrust, weight of the water displaced, buoyancy force, weight of water displaced. So go to next one. So the effect this is that all substances weight less in water. Take a brick in your hand, gently dip it in the water, and you can see the entire brick is underwater. So do you feel that the brick is now lighter? No, it is not. Yeah. So example of Archimedes principle here, the thrust and the gravity. Here 5 kg. So here you can take a. I am giving you few activities. Take a bucket of water, any like 1 meter long, half a meter width. So like the yeah, breadth or length, whatever. So then you take 5 kg any heavy material. For example, I mean, don't dip gadgets, of course. So take any rock or take any hard material. For example, take your steel bowl plate or whatever, dip it inside. Check first the kg. For example, it's like around round figure measure as 5 kg. When you dip it inside, the water would sometimes come out. You need to have a hole here, of course. So the water, you have to have another small bowl here so that water can come off. So you can just put that in the rock, whatever the item, heavy item. Then you see, um, like the weight will be less, and the water will come out some amount, maybe around figure as 2 kg of water. So here, understanding Archimedes principle here, as you can see, 6 kg, um, 2 kg buoyancy force here, here. So we're not gonna watch these. So let's apply the principle. Take a brick and a wooden block in the same volume, say 1 liter for examples. So and immerse them completely in the water. The weight of the brick is around 2 kg, while the wooden block is around 0.8 kg. Maybe if you know what is this called, decimals, then you will know 0.8, of course. So both of the both will displace the same volume of the water, and that is when the 1 liter. So hence both displace the same weight of the water, that is 1 kg, since 1 liter of water weighs 1 kg. So by Archimedes principle, the upthrust on both will be the same. So that is equal to the weight of 1 kg. Might be a bit confusing, but yeah, you need to learn a bit more on it. So it would be a bit easy for you. It's also hard. I'm not telling like it's easy. It's also hard for me. Well, just learn to put hard work in that. In case of the brick, weight 2 kg upthrust, 1 kg the brick sinks. In case of the wood, weight 0.8 kg, like more, the upthrust is more, and 1 kg the wood will float. So the rules for floating and sinking according to the Archimedes principle are: if the upthrust is more than the weight of an object, the object will float in the water. If the weight of an object is more than the upthrust, the object sinks in the water. Easy, simple. Uh, this question is repeating all the time, so this actually is a very main question. You can keep it in your mind as one of the examples. Why does iron ship float? How can that ship float? Like that. No? So, sorry. So, yeah, that's all. Thank you guys for watching. Hope you like it. I will see you soon in next video. Thank you. Bye.